Hello students, welcome to Educate. Today we are going to do numericals of chapter 6 of class 12 physics. So let's start. The first question says that we have to find out the direction of current using Lenz's law. Lenz's law, you know that whenever there is change in magnetic flux, then current will flow in such a way that it opposes the cause. Here as a pole is approaching, it means there must be S pole here. So to make it S pole, current should flow from Q R P Q, right? So this will be the direction. And let's consider second case. Here this pole is approaching, S pole is approaching towards this coil. It means there should be S polarity. Here what is happening? N pole is being moved away. So here S pole should be developed so that there may not be relative motion, or relative motion may be minimized. So what will happen? Direction of current will be here in this will be X, Z, Y. Here it will be Q, R, P. Right? Consider second case. In second case, here what is happening? Here when key is just closed, the current will start flowing in this direction. So here the current will flow just opposite. It will be X, Y, Z, or Y, Z, X, the same thing, right? Now consider this case. What is happening here? Again, here resistance, that is rheostat, is being changed, means setting is changed, and current flows in this direction. So in this loop, current will flow in such a way that it will oppose the change. So it will be ZYX. It will be like this. This current is coming like this, it will be like this, right? Here what is happening? Here again, initially there was current in this direction. Now what is being done? Here tapping key is just released. It means current is stopped. So in this circuit, there will be current, and its direction will be X, R, Y in this direction, right? And here there won't be any change. So this is simple question. Now let's see next question. Next question says, here again you have to find out the direction of current. What is happening in this question? A wire of irregular shape turning into circular shape. Area is being changed. So what will be the direction of current so that flux change will be minimum or may not increase? Flux change may be reduced. So for that, direction of current should be anti-clockwise. Current should flow from this A, D, C, B. Correct. Here what is happening? There is circular current loop. Now it is changed into the form of a flat wire. So area is being decreased. So direction of current will be such that it should oppose the change in flux. So it will be anti-clockwise in this loop. Here current will be like this. Alright. Now we are going to see other questions. So here there is one question. A long solenoid with 15 turns per cm has a small loop of area 2 cm square placed inside the solenoid normal to its axis. If current carried by the solenoid changes steadily from 2 ampere to 4 ampere in 0.1 second, what is the induced EMF in the loop while the current is changing? So here question is simple. So if you remember, B due to solenoid is mu naught N I, and E in magnitude is d phi by dt. If there are n turns, so we can write here n. Here number of turns is 15 turns per centimeter. In 1 meter, number of turns will be 1500, right? And then d upon dt of B, here B equal to mu naught n I. So mu naught n are constants. So here that I have written. So it's not necessary to write here n in that case if you are using this n. So just we can write directly. So E equal to here d phi by dt, and that is d upon dt of mu naught n I, right? So mu naught n, here one thing is missing, BA into A, right? Mu naught n A under di by dt, right? Then put the values. Mu naught is 4 pi into 10 to the power minus 7 into n is 1500 into A, area of the loop is given here 2. So 2 into 10 to the power minus 4, and then di by dt, current changes 4 to, this is just 2 and time is 0.1, and then we can evaluate it. This comes out to be 7.5 into 10 to the power minus 6 volt. It's simple question. Now consider next question. A rectangular wire loop of side 8 cm and 2 cm with a small cut is moving out of the region of uniform magnetic field of magnitude 0.3 Tesla, directed normal to the loop. What is the EMF developed across the cut if the velocity of the loop is 1 cm per second in a direction normal to the longer side, shorter side, and you have to find out the time also, and for how long does the induced voltage last. So as far as second part is concerned, in that case we can find the time, like t1 equal to distance, so whatever length it has, if it is 2 centimeter, here size 2 centimeters, so just write 2 cm divided by velocity, that is velocity is given as 1 cm per second, so 1 cm per second, so this will give 2 seconds, right? And for longer side t2, total length is 8 cm and velocity is 1 cm per second, so that it will take 8 seconds. So this is second part. For first part, we have to consider that motional EMF B, it is based on, it is E equal to BLV, right? So what is magnetic field here? 0.3 Tesla. Length is given as 8 centimeters, so we can write 0.08, and we can write velocity. Velocity is given as 1 cm per second, so 1 into 10 to the power minus 2 meter per second, so this will give volt, first value. Similarly, say this E1, and if you take another side, that is 2 centimeters, so B is 0.3 and L is 0.02, then velocity is 1 into 10 to the power minus 2, and you can get its value, that will be 2.4 into 10 to the power minus 4 volt. So I think it is simple, you can do it easily. Now let's consider next question. Here a 1 meter long metallic rod is rotated with angular frequency of 400 radian per second about an axis normal to the rod, passing through its one end. The other end of the rod is in contact with a circular metallic ring. A constant and uniform magnetic field of 0.5 Tesla parallel to the axis exists everywhere. Calculate the EMF developed between the center and the ring. If you remember, we have done one derivation also, that this is metallic rim, here there is wire, this rotates, there is magnetic field in it which is perpendicular, and this is fixed end, this rotates and it remains in contact with this metallic wire or metallic rim. Then EMF developed is given by 1 by 2 BL square, where L is the length and omega is angular velocity. So here we can put the values 1 by 2 into magnetic field. Magnetic field is given as 0.5 and the length of the rod is given as 1 meter. So write here 1 into 1 square, and omega. Omega is how much? Frequency is given 400 radian per second. So you can put the value. Is it omega? This is angular frequency. So here just write 400 and then evaluate it, you will get 100 volt, right? Now let's go to next question. Next question says a horizontal straight wire 10 centimeter long extending from east to west is falling with a speed of 5 meter per second at right angles to the horizontal component of Earth's magnetic field, 0.3 into 10 power. It should be minus 4 if it will be given. Here value is not given correctly. So we will assume we can verify whatever it has, its value is. So we assume that it is 0.3 into 10 power minus 4 Weber. So 10 power minus 4, right? If there will be any change value, that will be given. So you can evaluate accordingly. So here, what is the instantaneous value of the induced EMF in the wire? What is the direction of EMF? Which end of the wire is at higher electric potential, right? So let's see the situation. A horizontal straight wire 10 meter long extending from east to west. So wire is like this. This is east, this is west, right? East to west, and length is given as 10 meter. Is falling. Here speed of fall is given 5 meter per second, right? So what is happening? Magnetic field will be, since magnetic field is horizontal and this velocity is vertical, so in that case we apply the concept BLV equal to induced EMF, right? So we can put the value of B will be equal to 0.3 into 10 to the power minus 4, and length is given as 10 and the velocity is given as 5, and you can evaluate, so you will get answer, correct? And then comes, what is the direction of EMF? So here direction of EMF, this is what is direction, east to west, right? So here direction will be, EMF will be just like this, west to east, and you will have to find out which end will be at higher potential. Obviously if current is flowing, if direction of PD is like this, it means this will be at higher potential, this will be at lower potential, right? And then comes next question. Next question says current in a circuit falls from 5 ampere to 0 ampere in 0.1 second. So what is given? This is di by dt, right? Value of di by dt, it will be negative. So minus 5 by 0.1 ampere per second, and then average EMF is given. Average EMF means E is given 200, although it will be negative, so we can adjust it. Give an estimate of self inductance of the circuit. If you remember, E is given by minus L di by dt. So all values are given, so we can write this value 200. We can remove minus sign, or we can adjust it. 200 equal to L is to be found, di by dt is given 5 by 0.1 in or 50, so L equal to 4 Henry. You can easily get the answer. Then comes next question. A pair of adjacent coils has mutual inductance of 1.5 Henry. Value of M is given. So M is given as M equal to 5 Henry, and sorry, not 5, 1.5 Henry. If the current in one coil changes from 0 to 20 ampere in this, di by dt is given, it is from 0 to 20, so 20 divided by 0.5, that is 40 ampere per second, right? What is the change of flux linkage with the other coil? So d phi by dt, equal to m di by dt. So here we have to find out d phi by dt. We can put the values. So it will be how much? Value is given this 40 d phi by dt equal to m. M is given 1.5 into di by dt is 40. Correct. So you need d phi. So for that you have to multiply by dt. So 1.5 into 40 multiplied by dt. dt is given as 0.5. So 60 by 2, that is 30 Weber. Understood? So this is how the exercise is over. Thank you for watching. Team Educate.